Okay, so today is our last section before spring break, and we're going to learn about how to solve quadratic equations by using factoring. So if you remember from last chapter, we can factor trinomials into two binomials. We're going to do that again. This first statement, talking about the previous lesson, we haven't actually done anything with that yet, so just ignore that. We can solve some quadratic equations, including equations where b doesn't equal 0, by using the zero product property. Okay, so the multiplication property of 0 states that for any real number a times 0 just equals 0, okay? So that's basically saying that if we have any real numbers a and b, if a equals 0 or b equals 0, then that means that a times b also equals 0. And the zero product property actually reverses that statement. So our first box here is the zero product property that states that for any real numbers a and b, if a times b equals 0, then a equals 0 or b equals 0. So we're not sure which one equals 0, but we can set both of them equal to 0, okay? So when we're working on this using our factoring, we're obviously going to factor into two binomials, okay? So from here, what we're going to do is we're going to set each of these binomials equal to the 0, okay? So we should have x plus 3 equals 0, and we're going to have a separate statement that says x plus 2 equals 0, okay? So once we have our two equations set up, we are just going to solve for x. So to get x by itself, we're going to subtract 3 from both sides. That gives us x equals -3. And to get x by itself on this next one, we're going to subtract 2 from both sides. That gives us x equals -2. Okay? So if we go down further, we have our solutions to our equations, to the equation 4t plus 1 times t minus 2 equals 0. Then we can split this up, split it down the middle, and say that we can have 4t plus 1 equals 0. We can also have t minus 2 equals 0, okay? So to solve for t over here, the first thing we have to do is subtract this 1 on both sides. That leaves us with 4t equals -1. And to get this t by itself, we have to divide by 4 on both sides, which leaves us with t equals -1 over 4, okay? So that's our first answer, okay? And for our second, to get t by itself over here, we are just going to add this 2 to both sides. That leaves us with t equals 2. So that is our other answer. For all these answers, we should have, or for all of these problems, we should have 2 answers, okay? So if you want to start working on these got it problems, go ahead and pause the video. Remember, all you're doing is splitting them up and setting them equal to 0. Okay? So for this first one, we have x plus 1 equals 0 and x minus 5 equals 0. So we're going to subtract 1, that gives us x equals -1. And we're going to add 5, which gives us x equals 5. Okay? Over here we have 2y plus 1 equals 0. And we have y plus 14 equals 0. So that gives us -1, so 2y equals -1. Divided by 2. Y is going to equal -1/2. And we can subtract 14 from both sides, which gives us y equals -14. Down here we have 2x plus 3 equals 0 and x minus 4 equals 0. So that'll give us -3 minus 3. So 2x equals negative 3 divided by 2 on both sides, which gives us x equals negative 3 over 2. Okay, and we've got plus 4, x equals 4. And our last one, we will have 7n minus 2 equals 0, and 5n minus 4 equals 0. So we're going to add 2 on both sides, so 7n equals 2, and we'll divide by 7 on both sides, which gives us n equals 2 over 7. Okay, and we're going to add 4 to both sides over here, which gives us 5n equals 4, divided by 5 on both sides, which gives us n equals 4 over 5. Perfect. Okay, so if we move down to the next page, we can also use the zero product property to solve equations in the form ax squared plus bx plus c equals 0 if the quadratic expression ax squared plus bx plus c can be factored. I know you all loved factoring last chapter. We're going to use it again, okay? So if we come down to this first problem right here, we are going to see if we can factor x squared plus 8x plus 15. So we want to find our c, which equals 15, and our b, which equals 8. So if we go through and find our factors of 15, we have 1 and 15, and 3 and 5. 3 and 5 add up to equal this 8. So we should have that x plus 3 and x plus 5. And we're going to set that equal to 0 because this equal to 0 is on the outside. From here, we can use our zero product property and split them up. So we should have x plus 3 equals 0 and x plus 5 equals 0. When we do that, we subtract on both sides, which gives us x equals negative 3. And over here, we're subtracting 5 on both sides, which gives us x equals negative 5. Okay? So if you would like to, go ahead and work on the got it problems. Remember, you're just factoring these and then setting them equal to 0. Okay? So our c is going to be negative 14. Our b is going to be negative 5. Okay, so 14, 1 and 14, 2 and 7. So we have 2 and negative 7 that add to equal negative 5. So we're going to have m plus 2 and m minus 7 equals 0. From here we've got m plus 2 equals 0 and m minus 7 equals 0. Go ahead and solve for those. That gives us m equals negative 2 and m equals 7. Next one, we have our c equals negative 20 and our b equals 1. So we have 1 and 20, 2 and 10, 4 and 5. So we should have p minus 4 and p plus 5 equals 0. So p minus 4 equals 0 and p plus 5 equals 0, which means we have p equals 4 and p equals negative 5. This last one, we have to use the AC method, so our a times c equals 36 and our b equals negative 15. So if we have 36, we go through all of them, we have 1 and 36, 2 and 18, 3 and 12, We're going to use that 3 and 12. Make them both negative. It's where we should have 2a squared minus 3a minus 12a plus 18. Okay, so that gives us a times 2a minus 3, then minus a 6, which gives us 2a minus 3 inside again. So we should have a minus 6 times 2a minus 3 equals 0. So we can have a minus 6 equals 0, which means that a equals 6. And we can have 2a minus 3 equals 0, which means a equals 3 over 2. On to the last page. Okay, so before solving a quadratic equation, we may need to add or subtract terms from each side in order to write the equation in standard form. Okay, so this means that you always want to set your quadratic equation equal to 0 before you start trying to solve, okay? So for this one, we need to get this 18 over to the other side, so we have 0 on this side. So to do that, we're going to have 4x squared minus 21x. Since this is a positive 18, we're going to subtract it to the other side, which means we're going to have minus 18 equals 0. Okay, from here, we're going to have our a times c. So 4 times negative 18 gives us a negative 72. Okay, and our b equals that negative 21. Okay, so we try to find that. That's going to give us 4x squared minus 24x plus 3x minus 18. Okay, so when we are factoring this, that's going to give us 4x on the outside, which leaves us with x minus 6 inside. Then we have plus 3 and x minus 6 on the outside again, and this is all still equal to 0. That leaves us with 4x plus 3 times x minus 6 equals 0. From here, we can take them and have that 4x plus 3 equals 0. We subtract that 3, gives us 4x equals negative 3. Divide by 4, which leaves us with x equals negative 3 over 4. We also have that x minus 6 equals 0, which just gives us x equals 6. Okay, so go ahead and do the got it problem, and then you should be good to go. So we have our got it problem. First thing we need to do is we need to add this 49 to both sides. That gives us x squared plus 14x plus 49 equals 0. So our c is going to be that 49, our b equals 14. So if we go through all of our factors, we have 1 and 49, and we have 7 and 7. So that gives us x plus 7, and x plus 7 equals 0, which gives us x plus 7 equals 0. Our x is just negative 7, and x plus 7 equals 0 again, which still gives us x equals negative 7. Okay? So if we have quadratic equations in the form of x squared plus 2ax plus a squared equals 0, we're only going to have one real number solution because these are both going to be the same numbers, okay? So it's just because they're perfect square trinomials, okay? So they are perfect square trinomials. Okay, so you should be good to go.